Hello, everybody, and welcome to my cloud automation study group. We are currently knee deep into our series covering Kubernetes, and today specifically, I would like to go over the Kube-Scheduler and how it decides what pods that the goals are scheduled on. I would also like to preface this with you don't always have to use a kube schedule. In the cases that we do not have some of the architecture available, the Kubernetes core architecture available, we can go ahead and manually schedule the nodes by adding a specification for node name, and it's it accomplishes the same thing that kube schedule does by then telling where what node the pod should be scheduled on. Another way that we can also schedule without the kube scheduler would be through the use of static pods, and we will not be covering that today, but we will in the next session. So without further ado, let's go ahead and jump into it. The way we're gonna do this today is we're just gonna go through the practice test, and as I go through them, just you can stop me at any time and just ask any questions that you have. I'll also try my best to describe and explain everything that I'm doing. All right. So a pod definition file nginx YAML is given. Create pods using the file. So if you guys remember from last time, the pod definition file is going to be our YAML file that we can then use with the pod create, and we can pass the file to that to then create whatever resource is specified in that YAML file. We can jump into that file real quick just so we can see the structure of it. I'm not sure if everybody was here last week. And this is just a basic pod, and it tells you right here the type of resource that you're creating, pod, the API version, and the name, and then the image that we're gonna be using for the containers. And this is also the name that the container is gonna have. Uh, a little bit, so a lot of this is self-explanatory, but for the API version, you might not know which API version that you're gonna be using for the specific, because they have to match the type or the kind in the API version. So what you can do to find that out is you can do a kube CTL explain. So whatever resource you try to make, let's say we try to make pods, do a kubectl pod, explain pod, and it'll tell you the version that you need to use. Same thing where if you're trying to create a deployment, you type it correctly, it'll explain to you. In this case, it's you see that there's a group here. So this you would write as apps/v1. All right. So they want us to create that pod using that file. That should be easy. Does anybody remember from last week how we created that?
You said last week, then we used the deployment.
Uh, we can use a deployment, but in this case, we're just creating one pod. Do you remember how we would create one pod with a
little cube, something like that?
kubectl?
kubectl get pods.
The get command, if you remember, that will tell us what resources are already created.
So you're asking the deployment process. I think, if I remember correctly, you were using another, I think you called it Little Cube, but I can't remember the name exactly. But
Minikube.
Minikube.
Yeah, we were using Minikube, and so with Minikube, it has the same components as right now we're working in a full Kubernetes environment, but it has the same components. Like we still have our the kubectl get pods and dash a for all namespaces. We
Mhm.
still have all the same components such as our Kube proxy, Kube controller, API server, etcd. You have our core DNS. It has all the same components. They're just separated on different nodes. But what you can
Yeah.
do if
Some
you ever
replica or something like that.
go ahead.
Was there a replica? I'm sorry.
There is a replica set as well, and replica set will create multiple pods from that replica set with the same definition. So what you can do in the case that you do forget the command, of course, you can always do a kubectl -- help, and it'll list all the different commands you can do. And in this case, we want to create a resource from a file or from a standard input. So to do so, let's go ahead and do kubectl create -f because we want to use a file. So we're going to pass the -f parameter, and the file name is going to be our nginx, what they asked for. Yep. That makes sense? Creates our pod. We're good to go. What is the status create of the created pod?
Running.
Well, how do you know that it's running? I think you're right, but how do you know that?
You can just run. You'd have to say get pod. kubectl get pods.
Yep, let's do that. Oh, look at that. It's not running.
It's pending.
Why is it pending?
Well, it's supposed to be running, but maybe it hasn't.
Let's go ahead and we'll tell that it's pending.
There's something to do with the YAML file?
It does, possibly. Or it might have something to do.
Maybe because you don't have the services.
Well, how would you find
It's not a
out?
node.
How would you get more information on the pod that you're having an issue with?
Describe?
There you go. Good
Yeah.
stuff.
I cheated. I looked at the help.
That's
I
fine.
looked at the help that you just did up above. That's all.
That's fine.
Yep. Great use of the output. Nice.
CTL describe pod. And you always want to specify what type of resource that you want to describe, and then the resource itself.
The name of the resource. Okay.
All right, so let's see here. So we see here status pending, and we're not getting any errors, which would make you think that it never even tried to run it. So this is where we're gonna get into our taints and tolerations. So the taints, think about them as a definition or a configuration that you set for the node that will then only allow a specific type of pod to be ran on that node. So unless you have a node a pod that matches the taint that is on that node, it will not let you run that pod on that node. So you may ask, then how do you specify the pod can run on that node? That's where the tolerations come in which case you will set the pod like, hey, you have a toleration to this taint, so therefore you are able to go and run on that node that has that taint. Does that make sense?
So say that again, Des.
So you're able to have a node, which the node, if you remember correctly, it's the computer that the pods run on. The taint is a configuration that you're gonna set on that node that will only allow pods that have a specific toleration to be ran on that node.
Gotcha.
Okay. I'll show this in practice here in a second. So in
So
this
you have
case,
to configure the taint to allow the toleration
you have to configure the toleration on the pod
on the
to
pod.
be able to run on that taint, on the tainted server.
Okay. Okay.
We can let's do a kubectl describe well, let's first find out what nodes we have available. Get nodes. We have 2 nodes here. So then we can do a kubectl describe. Oh, I think it's gonna something else going on here actually. I just remembered. Do a kubectl get pods -a that we did earlier. If you remember, like, it wasn't even scheduled. So if you check here, we don't see a Kube-Scheduler. Yes, that's the reason why it wasn't able to run, is no scheduler present. Kind of got ahead of myself. Schedule the pod on node 01. So to manually schedule a pod, you would just specify that on the pod itself in the as a node name specification. So if we do kubectl edit pod nginx back node name, and they want us to put out node 01. I remember if there's only certain parameters that we can change with the kubectl edit, so it's not gonna let me actually it's not gonna it's gonna give us an error. You can see the only fields that can be changed are the image, initial container image, deadline, tolerations. That's it. So in the case of when you get this error, that it doesn't just update the pod. You can just replace it, which will delete the pod and rebuild it. To do so, we're gonna do ptl replace / force, and we can use the file that they gave us here. This temporary file -f temporary file. Well, copy it. Okay. Now if we do kubectl scribe pod nginx is now running, and it is running on node 01. See here. Let's check. Good. They want us to do the same thing, just move it over to the control plane. See if there's any gotchas. But we should be able to just change the name, node name. Control. Main.
This is a different node, so you don't have to do the taint or the tolerations.
I got ahead of myself. The tape and tolerations is gonna be on the next test.
Oh, okay.
Practice test. Yeah. So let's go ahead and do the same thing, replace it. Should have a new temporary file. Let's get here. You can use these temporary files even to create other, you can use them as a template to then create your next pod that you want to create. Paste. Right, it has been replaced. Let's check. Still building, looks like. Container is creating. We can do W. Oh, it's already created. That's it. Any questions on this lab?
No,
Go
I
to
like this though. I think this is the one. Is this the one that has the mock? Oh yeah, this is the platform that helps you prepare for the CKA the best.
yeah. Yeah, this is that platform. Let me to summarize is in the case that you don't have all of the components for Kubernetes for whatever reason that are part of the architecture, so such as your scheduler or maybe the API server is not working properly, and you need to schedule a pod to be created on a node, you can pass that node name specification to the pod, and then Kubernetes will know where to create that. And that's what the scheduler does. It just adds that specification to each node based on those based on a certain criteria that it has inside of itself. Like it has some orchestration built in where it's gonna check for the memory, the CPU usage, and the Taints and toleration. We'll get into affinities as well, and all these other things. But if you just need to, hey, I have this pod, it needs to go on this node, you can just add that node name to the pod and it will create it there.
Nice.
All right. Let's go ahead and go to the next guy. And this is the test labels and selectors. So let's go ahead and jump into it. The labels in Kubernetes are used to link resources together. Pretty much, if you have, for example, with the services, they will look for those labels to know what pod is going to be using that service. And you'll get to see it in action here. So they have deployed a number of pods. They are labeled tier, environment, and this is business unit. How many pods exist in the dev environment? ENV. So we can also use labels, of course, to search Kubernetes as well. So let's do kubectl get pods. We can do -- label. I think it's -- label. To look. Do -- help. Helpful label. Have any explanation? Examples? let's try. It's not dash dash, just dash L. And then we're looking for the dev environment. So we're gonna do environment equals dev. Got 1, 2, 3, 4, 5, 6, 7. Just to make sure, I'm just gonna inspect one of these. CTL. Scribe. Pods. Up. Dash 1. Dash F. W. Okay. I don't understand. Whatever. Environment is dev. So I'm gonna assume that there is 7 of them. I wasn't misspelling it. Maybe the dash is it's like a hyphen instead of a dash. I don't know. But let's go ahead to the next one. Company pods are the finest business units. Do you guys remember the command we just used to grab those pods?
The describe or the get?
It is the get command.
Alright.
Get command, we're trying to find the resources. Get pods, and then we want to specify what pods we're looking for. In this case, we're going to use the dash L for labels, and we're looking in the business unit. And think about it, it's almost like environmental variables, where it's like there's like a key and then there's a value. The business unit being the key, and then finance is our value. Here we have 6 of them. And how many objects are in the prod environment, including pods, replica set, and any other objects? So here we're gonna introduce a new concept, which is instead of our guest getting a specific resource, we can just specify all, and it will grab all resources. And we're gonna do the same thing, dash L, to look for the prod environment. Production. Let's see, I think it was env environment equals prod. And we would just count all of these guys. 1, 2, 3, 6, 10, 11, 13. Oh, I counted those guys. Okay. 4, 5, 7. Identify the pod which is part of the prod environment, the finance unit, business unit, and the front end tier. So here we can use them as a string. So we just comma delimited string, just to add all of our different key values that we're looking for. That's tier, front end. That's the right way to say it, Pat. It's comma delimited.
Yep.
All right. And we just got one guy here, ZZXDF. All right, so next up.
That was an interesting command.
How so?
No, it was interesting, because like key value pairs, like you have it in there, env equals prod, and that's pretty cool, right? I mean, it's just interesting.
Okay. But Next up, replication definition file is given. Replica set definition 1 YAML. Attempt to create the replica set. You will encounter an issue. Try to fix it. Don't remember what the issue is, so we're just gonna try to create it and see what happens. Create.
So if I get this right, this lab is basically, yeah, I mean, as you creating it, there are problems, and the way to learn is to fix them, or trying to.
So they have a little bit of a combination. You have some where they'll tell you like, hey, do this for me, and then check if you did it correctly. And then
Got
you
it.
have some that's like they'll have a question, and you have to find the answer to that question by using the commands. And then they'll also give you somewhere like, hey, like this one, create this, and they'll give you an error, troubleshoot that error.
Gotcha.
In this case, we're getting an error here, invalid value, map string, tier nginx. Sounds like to me, I've seen this a few times now. The labels for the replica set seem to not match the label for the container it wants to create. And we can take a look at that inside of that file. So you can see here, this is our specification for our replica set.
Mm-hmm.
And the label here is front end, but the container that it wants us to create is nginx from this template nginx. So it's not gonna work. All the labels have to match for it to create that resource. So let's go ahead and just change this guy over to nginx. And we can take a look at kubectl get pods to see if it created it. Oh, we haven't created it yet. So there it goes. Create a replica set. And there should be 2 replicas. So let's make sure that there is 2. There's 2. The containers are being created right now. And they are running. That's it. That's it. Any questions on the labels? Okay.
Not for me.
I mean, we need the labels for what again? I'm sorry.
So the labels are necessary for when you want to associate 2 resources.
Okay.
The biggest one that you're going to encounter the labels on is when you're creating services. The way you assign a service to a pod is through labels.
Okay. Okay.
And also when you're creating resources that, like, for example, a deployment, or in this case, a replica set, where the resource you're creating is creating another resource for you. The way it has those resource, the labels have to match for it to be able to create those resources.
Okay, got it.
Okay, here we're gonna jump into the taints and tolerations that I was mentioning before. All right. First things first, how many nodes exist in the system? Does anybody know how to grab that?
The code get, Kubectl get, yeah.
Yep, Kube-Scheduler get. We got 2 nodes here. We got our control plane and our node 1. And control plane is gonna be our master node. Just a fun fact, control plane usually has, or the master node usually has a default taint where it does not let you schedule any other pods onto it. So you'll only see the core components, the core master node components on there. Of course, it is usually set to no schedule, which means that no new pods will get scheduled there. You can circumvent this by manually setting a pod to be scheduled there. The other specifications that you can add to a taint is you can set it to prefer no schedule, in which case it will try to schedule, it will try not to schedule a pod onto that node, but in the case that there is no other node available, it will go ahead and schedule it onto that node. So an example of this is if you have 3 nodes in the control plane has a prefer no schedule taint on it, and the other 3 nodes are out of memory, it was gonna schedule that pod, the next pod on the control node because it's a prefer no schedule. If it's set to no schedule, the node that you're creating, the pod that you're creating, will stay in pending state and will not get scheduled until resources are freed up on other nodes. Uh, the other the one other one is gonna be a no execution parameter, in which case even the pods that are already created on that node, if they don't match that taint, they will be ejected from that node. Therefore, like they will have to get rescheduled on another node. With the no schedule, if a pod is already running on that node, it will keep running until it naturally has to get recreated or something else happens. Does that make sense? I hope I did not lose anybody.
No, we're here.
All right. So how many nodes exist in the system? We got 2. And then do any taints exist on node 1? So to get the taint, we're gonna go ahead, kubectl, describe our node. If I can type. Node 1. And just to make it a little easier, we're gonna do a grep command. Grep lets you grab a specific text that you're looking for. And we can do a -I for case sensitive. And we're gonna look for taint. And we can see we ain't got no taints. Do any taints exist on node 1? No. And just to show you what that looks like if you don't grep for it, you would have to go search it through here, try to find the taint, which is right here. Taints none. So if you do end up taking the test, make sure you make use of the grep command. It is very helpful. All right, next up, create taint on node 1 with key of spray, value more taint, and effect of no schedule. So let's go ahead and do that. Kubectl. Create. Let's do a dash help. All right, we could also do a double tap, and it'll tell us all the different commands here. Yeah, so we can update the taints. So let's do taint. Node 1, and do a dash help on here. Gives us some samples. Key value. We're looking for a key value one. Beautiful. This is what we want. So and it wants a spray and Mortain. Spray equals Mortain, and then the effect, no schedule. All right, who likes that? And we can verify that by describe node, grab taint. There's our taint right there. Spray more taint. So just to explain this a little, so now the toleration, like if a node has to be, you want a node to be placed on here, it has to have that toleration of the same key value, or it will not be scheduled. Go ahead and check. That looks good. And let's create a new pod with the Nginx image. Pod name as mosquito. kubectl or kubectl. And just do a run command. Yeah, run. Because we're just creating one pod with that's running one image. Use the run command. Image Nginx. And don't forget to specify the name of the pod. Mosquito. All right. What is the state of the pod? Kubectl. Yeah, pods. Pending. Why do you think the pod is in a pending state? Let's find out. What was going on with the mosquito pod?
I found typo. Yep.
Okay. So if you remember the difference between last time when it was pending versus this time, now we're actually getting error events, which means it
Mhm.
did try to schedule it. When you have no error events, it means that you didn't even try to schedule, which it's a component issue that there was nothing was there to schedule it. So if we
Can you
read
do,
into this,
can you do a get pods describe? I mean, you did the describe. Is there?
correct.
I don't see or the image is Nginx.
Yep.
Does it have a version?
In this case, we're just using the regular Nginx image. But you can look at the error messages down here. So you see it has in Kubernetes the error messages are logged as events. And you have our warning here. Failed scheduling. Default schedule 0 out of the 2 nodes are available. One node has untolerated taint, and the other node also has an untolerated taint. This here is the default taint that goes on all the control plane or all the master nodes. So we're able to see here that the reason why it wasn't able to schedule it is because it's not tolerating any of the taints that the 2 nodes have. So we come over here, cannot tolerate more taint. Create another pod named B with Nginx image, which has a toleration set to the taint more taint. So let's go ahead and keep still. This is where we're gonna use our dry run command. Run. I'll show you what I mean. We want to create a template for ourselves instead of just writing all that out. So run b image Nginx, and we're gonna use the dry run client side with an output for YAML file. And what this does, if you just write it like this, it'll just spit out the YAML file for th for this command, for this imperative, because you're running an imperative command. This is the YAML file that you can then use to run a declarative command. But then you can use this as your template, right? Because you already have it. So what we can do is we can just output it into the YAML file in this code. I'm gonna name it b.yaml. Then vim b.yaml. We have all of our template here. So then we can go ahead and add the image name, key spray. So we just need to add a toleration, right? So for that, remember we have access to the Kubernetes documentation. So we can say search toleration. Let's see what we get. Taints and toleration. Let's see here. Tolerations in a pod. Yep, this looks like what we're looking for. Can just copy that. So, and we just said the key spray value. Oh, in this case, okay, so there's something that you should be aware of. The operators, operator exists will take place in place of your value. So then it just looks that the key exists even if it doesn't have a value assigned to it. But in this case, we want a value, so we're gonna get rid of this and put value. Chain. Like no schedule. Good to me.
It doesn't need the quotation marks.
Yes, it does. Good catch. Okay. Okay, so now we can go ahead and use that YAML file, kubectl, create f. Let's take a look, see if it got scheduled. Kubectl, get pods. And looks like B did get scheduled. Can check stuff. Any questions? I know that one was a bit long.
So if you want a mosquito to run, you will add that toleration.
Correct. Exactly. And the toleration just has to match the taint that is on the node.
Okay. And that's for one of the nodes. If you wanted to move it to another node, you would have the key value for the other taint.
Yep.
Okay.
Got it. That is
But that's
bpod
what the whole
rescue.
point of all them labeling and stuff is. Okay.
Yeah. We'll try to. You can get even more granular when we start getting to like affinities, where you kind of just you're pointing instead of you setting exclusions of where things can be created. With affinities, you'll be able to point where you want it to be created, and we're gonna use labels for that. But for now, let's look at the taints. Do you see any taints in the control plane node? Yes, we saw it earlier. Still have it here. Node control plane. Oh, earlier. We are kubectl describe node control plane and pipe it into a grep. Taint. No schedule. Alright, remove all the taint on control plane which currently has taint effect of no schedule. That taint. Curious if you can use a taint command to remove a taint. Dash help. Remove from node full all the taints with a key dedicated. Dedicated minus. Okay, so follow that. Control plane, and what was our taint there? Control plane. Copy that and paste it and put a minus at the end. Let's see. Untainted. Oh, look at that. Did not know that you could do that. What I was gonna do is I was just gonna edit the the configuration and then recreate it. But then that simplifies it. What is the state of the pod mosquito now? So let's it probably what do you guys think is the state of the pod mosquito?
After making all those changes,
Mhm.
it says untainted. So let's find out.
We just untainted the control plane node. And if
Mm-hmm.
you remember earlier, the mosquito pod was pending because it did not have any
You have a
tolerations.
Yeah.
So what do you think is the state of the pod mosquito now that we've untainted that node?
Should be up, right? Available.
Yes, it should.
Mhm.
Yeah.
That
Mm.
now running. Mosquito is now running.
So it didn't need the toleration if it's untainted.
Yes, correct. Because
Okay.
if the node is untainted, it's just like any other node. The Kube-Scheduler is just gonna drop
Mm.
that pod right on there.
As if it was the only node. Okay.
Yep. Which
Okay.
node do you think the pod mosquito is on now?
What label did it have? Was it like node 1?
Well, we're just talking about nodes. Just think about what just happened. Um, we untainted a node, and
Mm.
mosquito, which did not have any tolerations, then became running. So which node do you think that pod
Maybe it's
is now
B
running
because
on?
we created the tolerations.
Say that again?
I said, is it B because you created the tolerations on that one?
So no, B is a pod as well.
Oh, okay, okay.
So you
Oh,
want to look at the node, which is like the server
mhm.
that
Yeah. I
mosquito
try
would
to
not be
remember the
running.
node names. I can't remember node
I
names.
can't
They're right here.
remember. Where did I put
If you
it?
read it, our option is gonna be our control plane, node 01 and node 02.
Oh, okay.
See, I don't see that on my screen.
Oh, what do you see on your screen?
I just see control plane and it's got an arrow, green arrow, and I see cube cuddle, get pods with the pod information. I don't see the node information.
Uh, on the left side, do you see the options for the question?
Oh, I see it
Good
now.
enough.
Okay. Okay. I
Oh,
see it now.
If you look just a little bit above that, this is
Also, it
the
should be control plane then.
I didn't even see
correct.
that. Okay.
Okay, control plane.
And we can,
Cool.
before I end this lab, we can confirm that by doing a kubectl describe our pod mosquito. And if you look here, our node is control plane.
Mm.
And think about it like this. It's like if you have a container and you have a dam. Let's go with a dam and an empty basin. The taint was your dam, and once you remove that taint, the dam is open and the water just flows in there. So as long as there's space, as soon as you remove that taint, all the pods that were pending are gonna go into the first available node. Hopefully I did not make that more confusing. All right, let's go ahead. Let's keep it moving. I think we can get through one more here. Node affinity. This is the fun stuff. So with node affinities, you are able to tell you specify these on the nodes, and you're able to tell the node like, hey, I want you to schedule yourself based on these policies. Um, and we'll get into that here shortly. All right, how many labels exist on node O1? Let's first look at how many nodes we got here. Get nodes. Got 2 nodes. And how would we get the labels for those nodes? Any ideas?
Well, you get the labels. Don't you get?
That's correct. No, sorry. That is
No,
because you're trying to find the node that exist, the labels that exist on node O1.
on the node. So you're gonna describe the node to do that.
There you go. There you go.
Yeah.
Node O1 grep label. Should be able to pull it, right? All right, dash I. Okay. All right. So, just to make sure, because grep is only gonna pull one line, I believe. So let's do a C. C pulls lines in both directions. Really, we just need a B here to pull the lines after, and we'll just do 10 lines. Okay, so we were good. Just one label. No, it's not one label. Oh, my bad, yeah. The opposite. A pulls the lines after, B is the lines before. That makes more sense. Okay, so we have 5. And I guess I'm realizing now a good way to remember that A for after, B for before. What is the value set to the label key beta Kubernetes IO Arch? So if we look over here, we can on node 1, so it's the same node, Kubernetes Arch right here, AMD 64. And these are just key value pairs. So when they say value, they're looking for the right side of the equal sign. Apply label color equals blue to node 01. So I actually did not remember how to do this, so we're gonna find out. Apply label. Oh, I believe it's just label. Yep. Node 1. No, we don't want that. I believe it's just gonna be our key value pair here. Color is blue. And if you were trying to just get a confirmation if the command will even run, you can do a dry dash dry run. It's client side. Looks like and when you get this, it means that it does run. It'll give you an error if it cannot run. So then you can just, yeah, you can just run this. Our label is created, and we can do that command again. We see here, color blue label is added. Create a new deployment, name blue with engine X image and 3 replicas. We've done this a few times now. Does anybody want to take their chances of doing this?
So we up to here now. Now you've done you've already, so you grab the labels.
This question is gonna be completely independent of what we did previously. We're just gonna be creating a new deployment named blue with the engine X image and 3 replicas.
Oh, okay, so you're basically repeating what you just did in a different way. I mean, with a different name, actually.
Yep.
You don't need any new pods or anything. You're just doing it all within the same node,
Yes.
making 3
So
replicas.
with deployment is gonna be your, think about it like a configuration that sets up your orchestration. And with a deployment is gonna create a replica set and then manage that replica set. And that replica set is gonna create your replicas of your pods.
Mm-hmm.
So I'm assuming you have the well, not assuming, it's fact. You have the commands in your history, right? Buffer. How about we collect them and put them into a little bash and cheat our way into it, right? Just build it quick.
Well, you can actually do this in one command.
Oh, really? All right.
So this is a little this I went over this a little bit last week,
You did last week, yeah.
but it's been a while, so I'll go over this. You're gonna do a kubectl create, and we're creating a deployment with the name blue. So you're gonna specify, usually the way the syntax of kubectl is kubectl the action you want to do, the resource type you want to do it to, and then the name. In this case, blue. And
So what do
then
you mean by resource type? Deployment can be replaced with production, dev, all that good stuff?
no, so there's
Okay.
specific resource types. You have your deployments,
Mm-hmm.
you have your replica sets, you have your pods,
Okay, gotcha.
nodes, like label is a resource type. Services is specific. It's not something that you are creating. They're already defined in
Gotcha.
Kubernetes. But the name is something that you are creating yourself. So create deployment blue. with the
For
image
me,
nginx.
regarding, it's always helped me out to regard the deployments as like a template. So it's like a template, but then you configure like the specific aspects of it the way that you want. But it's like the framework of it pretty much dictates how the pods are going to be deployed and the nodes and everything like that.
Yep, that's brilliant. Yeah, that's exactly what it is. It's the definition of how those pods are going to be created. Yeah, like a template. So once you have your deployment and the name of your deployment, then you're going to be adding your specifications for your deployment, defining what that template is going to look like, as Sim said. So we're going to go ahead and do, it's asking us to set the image. So for that, we're going to do our image mention X. And then it also wants us to have 3 replicas. So replicas 3. And just so you guys see what this looks like. Oh, yeah. Wonder if this is gonna do both. Alright, so this is what that YAML file would look like if you were to write it out yourself. And once you start getting into these deployments and these bigger files, it is much easier to use this Kube create commit and then do that dry run that I showed you earlier and pipe it into a file. And then you can edit each of these file specifications like the labels. And if you need to add certain things, you can add it to that. But you're not starting from nothing. And if you remember earlier, I showed you the explain command. Here's what
Mhm.
that group and then API would look like if you write it out into your YAML file. It's apps/v1. All right, so let's go ahead and actually create it. Oh, so that's what I wasn't sure. If you don't specify the dry run command, you will get the output and then it will also create it. So blue already exists. Which node can pods for the blue deployment be placed on? So it says here specifically, check taints on both nodes. First, let's see if any pods were created. kubectl get pods. Looks like they're all running, so can be placed on one of them. We can't cheat and get a describe pod. We'll describe all of them. And let's see what node they're running on. Node 01. So looks like they can be placed on node 01. Interesting. But they're running. How does that work? Oh, did it come? No. There's no I didn't add no tolerations. But let's go through how they want us to do this. They say check the taints on both nodes. So let's go ahead and check that. I'm so surprised because they are running, right? I'm not blind. They're running. All right, let's check the taint.
Try to describe it again, right? See if it just delayed.
Bribe. They want us to check the taint on the nodes. So let's look at what they're talking about. Bribe nodes. One, the other one control plane. Then we're gonna grep or I taint. Oh, okay. They got me. It can be created on both because they removed the taint on control plane, which if you know, there's a default taint on control plane. Or was it? Did we remove it early? I think we removed it earlier actually ourselves. So in this case, it can be created on both. And set the node affinity to the deployment place on the pods to place them on node 1 only. So this is the affinity they want us to create. And we're gonna use our handy dandy documentation. Let's look up affinities. Samples to nodes, samples using node affinity. We got, and here's what we want. We want this here. And I'll explain what all this means in a second here. So to do so, we're gonna go ahead. Oh, we didn't actually create that. So we're gonna go back to this command here. We wanna do a dry run. Client. YAML. And standard input into, we're gonna name this blue.yaml. All right, and we're trying to change. Let's see here. Containers. The spec for the deployment. Well, this is for the pod. They have one where they're doing deployments. Okay, this is, we're just gonna have to go off of my knowledge where I know. We're gonna find out if I know or not. But we have to specify this on the container and not on the deployment itself. So let's go ahead and go down to the container. Paste this plain text, affinity. Fix this a little bit. Compare that. Key should be right under the M. And the indentation are important when you're working with YAML files. It will not read them if you have them off. Just double check them. It's good. Then we're just gonna, okay, so for a node affinity, with node affinity is gonna look for the label that you add here, the key value, and it's gonna try to assign this, depending how you specify it. If you say in, it's gonna make sure that it's required during scheduling, ignored during execution. So okay, so required during scheduling, which means that when you're scheduling this pod, it is a requirement that the pod is created with this affinity. So in whatever we specify here, it has to be created or it will be pending until it matches. Until it matches you to a node that has the right affinity, the right labels. Uh, and ignore during execution, meaning that the ones that are already created is gonna ignore them. It's not gonna try to change them. Uh, there's another option is preferred. Let me see. I have it written down somewhere. Yes, preferred during scheduling, in which case is not a requirement. So in the case that there is no other node available, it will schedule it on a in the case that there's no node available that matches the affinity, it will schedule it on whatever node that is available. With required, it will stay pending. And something that is not implemented yet but will be in the future is preferred during execution, where during execution, or sorry, required during execution, where if a node is already scheduled and this gets updated, that node will get ejected and we'll have to find a new node. Sorry, that pod will get ejected and you have to find a new node that matches the affinities. I know that's a lot, but we're gonna see it in action here in a second. So the name is blue, replicas 3, and Nginx is the image. And we want the required during scheduling, nor during execution. That's already set. And our keys, we're gonna want to do color equals operator in blue. So it's good to me. Let's take a look here. Don't quite remember what the operators mean, so let's see if it says it here. Should have it here. Do a control F, which is that's gonna be useful when you're on the test. You can control F so you don't have to search the whole thing. Do not in. Use operator field specified logical operator Kubernetes rules. You can use in, not in, exist, doesn't exist, GT. So what? Nice of them not to explain it. Okay, here we go. The label value is present in the supplied set of string. Okay, so in our case, the blue is present as one of the values in keys. Not in would mean that it's not present. Exists just means that the key exists, and does not exist, we'll check that the key does not exist. Okay, got it. See, and blue already exists, so we're gonna have to do a replace on this one. You remember correct? If you remember kubectl replace, just if you just run the command by itself without the force, it's gonna try to just replace what you changed inside of that resource, which I'll just show you here. That should not work. Place it's in the blue. Well, I'm still corrected. Yes, affinities is one of the things that can be changed. So there is certain parameter specification that can be changed using replace command. Most of them cannot. In this case, it can be changed, so it just replaced it. In the case that it cannot change them, you would have to add a -- force parameter, which will then just delete the old container, the old pod, and recreate it. So let's go ahead and replace, and we can check. All right. Which node are the pods placed on? We added the affinity that we added. For color blue. So, and do you guys remember which node that we added the color blue label to?
We're gonna have to describe, right?
It was node 1, right?
I think it was node 1, but I'm not 100% sure. So I would just
Okay.
describe node. You can run both nodes here and grep a 10 lines table. And let's see which one has the blue. Looks like that's gonna be. Oh, that doesn't tell us. That's good. Let's do a. See.
Oh, it's a control plane.
Node 1,
Oh, node 1
the one that has the blue.
with the blue, yeah.
Control plane does not have it. Yep. So you were correct. It is node 01. Question is, which nodes are the pods placed on now? We haven't checked, but just based on this, they should be placed on node 01. And if I am taking the test, I would just double check, make sure that you didn't do something wrong. Just do a kubectl get command on the pods and just see for yourself where they were placed. All right, let's create a new deployment named red with engine X image, 2 replicas, and ensure it gets placed on the control plane only. And it's telling us to use this key right here. So I'm gonna get us that template real quick. Yeah, great. Comments. The name red. Image is gonna be engine X. Replica is gonna be 2. Try run. Client. Output as YAML, and you can actually output this as JSON and a couple of other outputs formats as well. But of course, kubectl uses YAML files, so we'll stick with YAML. There is certain commands that do need JSON files, and you can change it when that's necessary. YAML, and we're gonna put that in red.yaml. And red YAML. All right. And we want to set. Oh, before we even do that, let's take a look here. So I want us to use this key that is present on the control node. So let's take a look at that. Control node, the key is right here, control plane. And as you can see, it doesn't equal anything. We'll keep that in mind as we create this. Let me see, do I still have it saved? Assign pod nodes using affinities. We'll come back down here. It's affinity. But do you remember that set paste? Is that what it was?
Yeah. So
With a space?
colon set space paste.
And enter?
Yeah.
And you just
And
control
then
S.
and then you just do your insert, right? Whatever you want to paste as. What are you trying to do? You trying to copy some lines down?
I have something copied. I want to paste it.
Yeah. So insert and then paste it in.
And do I do Control V? Or do you right click?
Or right click might work. Yeah. That's not what you wanted.
It's close enough.
They
Also
should have
the
copied it as is, though. They should have pasted it as is.
affinity, yeah, the affinity moved, but everything else looks good.
Okay.
Go ahead. Release insert mode. This. I'll try something else here. Shift V. Way to.
Or what you want to do is, how many lines are those?
We want to move him over 4 lines.
Okay. Nice.
There we go. Okay, that actually did work. Cool. So, yep, that's perfect. Everything
Yep.
looks good. Okay, so our key value here is, I want to also check the affinity. We do one required during scheduling, nor during execution. And our key here is going to be node control plane. Copy that. And then instead of having a value, we're gonna do exists to signify that we just need this key to exist. We don't care about the value that's assigned to it. Okay, everything else looks good. Make sure this is in line. Looks like it's in line. All right, so then we're gonna do our kubectl create from the file read. All right, we got an error. V1 cannot be handled deployment strict. Doesn't like our template. Did I put it in the wrong place? Containers. Insert. Let's have a look. It's in line. Oh. Oh, I didn't see. Yeah, that's our issue right there. Did it move? Shift V. Not enough. Want to do 2 more lines. There we go. Should be good now. Alright, perfect. And let's take a look. kubectl. Yeah, pods. Our reds are running. So let's check. It likes it. Any questions on affinity and labels? So just to summarize real quick, we use affinities. Well, first you would have to assign labels to the nodes, and then we are able to use affinities to direct the scheduler to schedule the pods based on the criteria. If you're setting it not in, exist, you're telling how to handle that scheduling of those pods to the nodes that have the same labels.
Okay.
While with Taints, is more of a blacklist where you're telling nothing can get scheduled here unless it has that toleration set on the pods. All right. That's all we're gonna get through today. Any questions on any of the stuff we went through today?
And it's Kubernetes every day. I find out it's no joke.
It's not no joke.
Yeah, that part.
Take a look here. Think I'm 23%. Like we still got a long ways to go. So
it,
yeah,
it,
go
it
ahead.
does. At some
Yeah,
point, are you gonna kind of like build it out, like just a Kubernetes environment, running an app or whatever? But are you eventually gonna build it out?
of course.
Okay, cool.
If you remember, I already have my Jenkins environment.
Mm-hmm.
Or I guess no, we have a Argo CD environment built in Kubernetes. I'm stuck right now on the services and getting the networking right. Uh,
Okay.
Going through this, hopefully we're able to get enough information that I can get that connected, that we can run it in the cloud instead of having it to run locally. Any questions on the Kubernetes stuff?
I'm trying to see what's the benefit of doing affinity over the tanks and tolerances. It seems like it's more security that the other way than affinities. But yeah, I'll quiz you on that some other time.
I would say it's just a case by case, depending what you're trying to accomplish. Uh, and it just might be easier done with a taint. Because for example, if for your master nodes, it's much easier to do that with a taint than it is with an affinity for you. Because then you still have to deny all the other node or the other paths from being added to that node. So actually, let's go back. There was a cool little explanation here. With that, I am gonna cut the sound out here just to avoid any copyright issues. And I can just do a quick explanation of what they're trying to represent here. With node affinities or pod affinities, uh, and taints and tolerations, we will tend to use both depending on the circumstance. In this case, that we want the colored pods to end up on a specific node, we would still want to use our tolerations so that none of the gray ones can appear on those nodes. But at the same time, we would still want to have affinities set to those colored nodes or pods just so that they can only be scheduled to the colored nodes. Uh, and same thing with the gray ones. Those we don't really care where they're gonna be scheduled on. We don't need to set any affinities. And same with the gray nodes. We don't need to set any taints. Therefore, the gray pods don't need any tolerations. Um, just when you're in a production environment, you're gonna be mixing and matching just so you can get your desired outcome, and you just kind of have to judge how you want to set that up. Uh, with that said, this was the last question of the night. I appreciate anybody that is watching on YouTube, and I did tell everybody that was in the group. Thank you for participating. They did a great job taking in the information, and there was a lot of it. With Kubernetes, it's a massive system. So I will continue uh, coming out with these videos. I would just like to ask for you to like, subscribe if you found this content useful, and if you have any questions, you can leave a comment or send me an email or communication on LinkedIn. Everything will be in the description. I thank you and appreciate you, and I hope to see you around. Thank you. Bye bye.